Something I want to try is filming myself talking about various topics. So today I want to talk about a server I wrote a couple of years ago called HTTPS Forward. This is really helpful if you've got a Ubuntu machine somewhere locally or on the internet somewhere. In my case, there's a server under my stairs. I was very happy with this when I built my house because it's got a network port and a bunch of stuff there. It's my little, home away from home that's about half a meter tall. But let's talk about it. So I'm a web developer, and that means I run things on the web. Either I'm doing local development on some random localhost high port, or maybe I'm running some service that needs to run, and it's really dumb, right? It just runs HTTP. What HTTPS Forward does is, if it receives HTTPS connections, it will go out, fetch a certificate for you, and then forward onto those local development ports or local servers that you're running. So here's the example. I'm running a local dev server on port 9000. It's totally boring. It's whatever you want it to be. In my case, this is Node running a static development server for Emoji Typer, which is great, a thing you should check out. Now, the whole value of HTTPS Forward is that I can go to its config and set up a line here. So I'm entering a domain name that I own. In this case, it's a wildcard domain, which I highly recommend. That means I can have any name under my larger host name. And it then forwards to my server running on localhost. Now, there's probably plenty of ways to do this in the real world. You run some server with Amazon or Google or whatever, and they'll get your certs for you. But in my case, this is something I want to run at my house or on a machine that I actually physically own. So the way this works is I've set up this domain name to forward to my IP address. And since I'm at home, my router is set up to forward port 80, which is HTTP, and port 443, HTTPS, to my server. Because it's got a local IP address, it doesn't really know about the internet, turns out. And when it sees a request coming in, it'll go, great, I know about this domain. I'm going to go ask Let's Encrypt for a certificate. That happens transparently, nothing to do. And once that certificate comes back, I'll serve what's actually on localhost to you as a user on that remote domain. And so here it is in action, right? I can load this domain up and it looks fine. Early on, I mentioned Ubuntu. And that's because this is really just a Go binary, but I distributed it via Snapcraft, which is Ubuntu's kind of not quite apt, but a binary distribution store where I can get a bunch of random stuff. There's some nice benefits to it, actually. The things running there are mostly sandboxed, and in this case, I need to listen on low ports, which means I need to run as root. Normally, you'd run sudo for that. And you do need to sudo to install, but that binary that gets installed only has permissions to run on low ports. It can't read your files or whatever else, and you can see this in the snap config file. So it's a really reasonably nice way to distribute stuff that's not really so highly trusted, but is still stuff you want on your machine. So this morning's filming is done because I've been interrupted by a small child who really is not interested in hearing Daddy talk anymore. I hope this has been interesting to you. I might do more of it. We'll see you around.